Hello, everyone. Good afternoon. My name is Anand. I'm from Reddit, here to talk about how Reddit scaled to 1 billion plus video views using AWS. And the session now ID is CTD320. So a little bit about me. So I grew up in India and moved to the US to work, to do my master's at Purdue University. And then spent about 8 years at Microsoft working on a variety of different things. Compilers, big data connectors, Excel connectors, and most notably, I spent like over 3 years as the engineering manager for the Power BI team and scaled it up from 0 to 5 million subscribers. Here at Reddit, right now, I'm a director for their AI and machine learning group called the Knowledge Group at Reddit. And in the last year, I've worked on several different things, like the web platform for Reddit, the native video platform that I'm going to talk about today, and as well as I led the redesign, the Reddit redesign, massive redesign from its original inception. So this is kind of what I'm going to cover today, give a high-level overview of what Reddit is, the Reddit architecture, and talk about why we built video, and a deep dive into the video pipeline, and walk through some results and some lessons learned. Quick poll, how many of you use Reddit here often? Oh, nice. OK, so I can breeze through these slides soon. So Reddit is a platform for finding different communities that you're passionate about and where you can have authentic conversations. As most of you know, Reddit, you don't need a real identity. Because of the pseudonymous accounts, you get authentic conversations. And at the core of Reddit is communities, where Reddit is powered by community and community rules. So we have communities for video. You follow their rules, only post videos. And so yeah, check it out if you haven't already checked it. For even people who use Reddit often, they don't know how big Reddit is by the numbers. So Alexa, for those who don't know, it ranks the websites by their engagement and the time spent on the subreddit, on the site. So Reddit is at 5th in the US, ranked 5th in the US and 14th globally. And we have about 330 million monthly active users and about 138,000 active communities. And with 12 million posts per month, 96 million comments per month, and 2 billion votes per month. So that's a lot of millions of people, a lot of content. So how do we build this one? So let's dig into what the site looks like. So this is a very high-level overview of what the Reddit architecture looks like. And it's focused mainly on the core experiences. I've left out some interesting pieces like the data analysis stack, machine learning stack, ad stack, but like this is what powers the core Reddit experience. So the one in the middle, it's called the giant blob. It's called R2, what we call as R2. It's an original monolithic application which has been Reddit since 2008. And this is one big Python blob. And we'll talk about a little bit more detail in the coming slides. So we just added a new front-end applications. Like we had a handful of front-end engineers who really got frustrated with the outdated technology in R2, where last January, a couple of my engineers went and built node-based modern applications, and it shares code between client and the server. And these front-end applications are basic. It acts like any other third-party API clients that Reddit has. So it uses APIs through the gateway or talks directly to R2. We are also in the process of splitting the monolithic R2 service into multiple microservices. So the key thing to note here is like each of these are individual teams. We have individual teams responsible for every one of those services. So we have a team for search, we have a team for listing service, we have a team for APIs, et cetera. So all of these new services are being written in Python, which was easier for us to split from our original Python monolith. And we also use a common library or a framework which avoided us to not reinvent the wheel over and over again when we are building these new services. And the framework also provided us useful things like monitoring and tracing, So each services can be plugged into a data pipeline. And these backends are using Thrift, and we also have a HTTP on the front end so that the API gateway can talk to these services from the outside as well. Like I mentioned, R2, the one we call as R2, is kind of the original Reddit, and it's really complicated, and it's a beast by itself. So I have like a blown-up diagram to walk through some of the key components of R2. So we have a bunch of app servers, and excuse me, same code is deployed to all servers, but excuse me, each server might be running a different request path, but the same stuff is deployed everywhere. And so we have also load balancers in the front, which uses HTTP proxy. And the point is to split the user requests that come from different clients and isolate them into application pools. It has been super handy for us to do this because let's say if our comments pages APIs are slow and it's running into some outages, when people try to visit the front page or they try to submit a post, those things don't get impacted. And it has been super helpful for us, and we didn't run into weird issues. And so along with the simple operations like upvoting and submitting a post, we also have some expensive operations that run, which we defer it to as an async job into our RabbitMQ. And most usually, those get processed pretty quickly. And in this section, which is the PostgreSQL and the cache and the thing which is highlighted below, it's the core data model at Reddit. If you think about the core of Reddit, which is comments, posts, subreddits, accounts, links, and any kind of post, all these are defined by using our core data model called thing, and it's stored in the PostgreSQL, and we have a memcache in front of it. And we have been using Cassandra for almost little over 8 years, and it's been super handy for us whenever we're building the new features. And one of the abilities that we really like about this is when one of the nodes going down, you can still continue using it. So that's a super high level of what the Reddit architecture for just serving the core Reddit experiences. So let's talk about why Reddit decided to build video, right? In Reddit, like, we have different types of contents: link posts, self posts, which is basically a text post, images, videos, GIFs, and also links. So, but turns out video is one of our most popular content types. And I just want to show a couple of sample videos that existed before we built this. Tell me if you don't like this. So that's a cat fist bumping a human with like about 1 million views, and this got about like, I think 100,000 upvotes. So it's a lot of engagement for contents like this. And this one, it's a cat walking a human. Clearly a future where cats are in charge. And this again got close to 500,000 views and 500,000 upvotes. So the videos is like really an engaging content in Reddit, and it's a core part of Reddit. Why else did we decide to build it? So it turns out if you had to submit a video post in Reddit, there's no native support. So we obviously wanted to do it for that reason. And as I mentioned earlier, communities are the key and the core part of Reddit. And we wanted to give communities new ways to express. And communities, what we have found in Reddit is they are super creative, and you give them something simple, they come up with like really interesting use cases. And the mobile opportunity, like our options are endless. We can innovate in our product. Before, we couldn't do interesting things. Like, for example, on the picture on the left, so if you're viewing a video post, when I'm scrolling through and looking at the comments, I can still see the video. We are able to do all those things because we could build our native video platform. And obviously, like, it's a really high engaging content, so people like media. So these were some of the key reasons. And the last one was around the way we did embedding for our video. Like, there are a lot of different third-party video sites, and it also helped us build a better performant experiences when we had our own native platform. So let's talk about what are the key problems now that we have trying to build it in Reddit. What are the problems that we were trying to solve? First of all, as I mentioned, we didn't have a native upload experience. It was really, really cumbersome. So this GIF talks about like how you go to a third-party site like Giphy or Imager, upload your video, wait for the video to be processed, get a link, and come back to Reddit, and then you find a community, and then you post it, and then pray to God that it is not going to get removed by auto mods or the community rules. So it was really, really extremely cumbersome. And so we didn't find a lot of new creators trying our experience. And the other one was, like I mentioned, is like the playback issues with when you don't have your native platform, we couldn't build interesting experiences to take into consideration of the slow network connectivity and the latest technologies. So all this limited engagement in our app, and we wanted to build a really clear user experience for these use cases. So we looked at why we need to build video and some of the video problems. I just want to walk through a couple of the key requirements we had to consider when we were building this platform. The first one was around post, right? It's straightforward. Like when you upload a post, it needs to go live once the video processing is done. And so we want to enable it at the right time so that we don't, with the way Reddit works, we don't want to penalize for the hot algorithm. And it also needed to integrate it with the existing AutoMod applications or the community validation or the rules, as well as have a really good experience built around the user getting real-time feedback. What's happening is when the video is getting processed, when it's getting done, and if it failed, what they need to do. And we also take privacy really seriously at Reddit, and so we also need to strip out the geo-tagging data from the video, and we'll talk about how elastic transcoding helped us do that as well. So that's on the post requirements from the Reddit post requirement side. In terms of the video, like we had a few other requirements that we need to take into account. So initially, or the primary reason we went with MP4 was for the performance reasons, right? Like serving a huge GIF to clients would be really bad. And so the way we supported GIF in Reddit today is like we take these MP4 videos and strip out the audio and then limit the video length to about a minute and let them auto loop the video. So that's how we do GIFs in Reddit. But we don't have a direct .gif support. And also some of the other, we also limited the length of the video that you could upload to about an hour or a maximum size of a gigabyte. And the GIFs were about like less than a minute. And we also built experiences around how you can, primarily we were targeting native audiences. So we also built the experience where we need to trim it out. And the last but not the least was the cross-platform. We needed to support in all the different platforms. And adaptive streaming was something we needed to take into consideration. It's something for performance, as like for degrading the connection speeds, how does the video perform well? So playback over low-speed environments needs to be considered. And we also had like Dash and HLS video types. Dash is for web and Android clients, and HLS is the Apple standard for all iOS and Apple devices. Oh, and the other requirement I messed out is like Reddit users are very change averse. So we also needed a way to build it in a way that we can roll it out to smaller audience. Like we can target a particular community and just let them in and then go from there. So these are some of the requirements. And I think the interesting requirement for this talk was probably around the infrastructure requirements that we had. So we wanted something easy to manage and handle the scale at Reddit. We call it sometimes hug of death. So when you build something for Reddit, you need to handle the scale of Reddit. We also need to deal with spiky demands. We have seen a pattern where 5 to 8 a.m. in the mornings, we get like a huge spike of video submissions. And external events like gaming, concerts, we get a spike of events. So we wanted to make sure we have the elastic capability in that as well. Of course, rapid processing time is something, key metric that we targeted for. As one of our KPIs that like when you build this video uploading tool, like the whole processing time should be in the right expected range. And the last one and the most important one for us was minimal in-house infrastructure. What I say by that is like at this time when we started building Reddit video, the whole engineering org, or the number of engineers in Reddit were like 40 engineers. And the people who were working on this video project were like 2 engineers. Like there was one engineer working on it half-time, and he was a manager, and another engineer working on it full-time. And we had a couple of vendors helping out with the client stuff. So like we had like really, really limited resources. And if you had to build this in-house like a transcoding cluster, it would have been a massive, massive undertaking. And we couldn't handle that scale. We probably need about like 30, 40 people just maintaining that transcoding cluster. And again, the FFmpeg transcoder system it brings with a lot of its own intricacies, and it's not something we didn't want to deal with. And the last one is for us is like monitoring and observability was really important. So these were some of the key requirements that we went in for building the video. So let's take a quick look at what the Reddit video pipeline looks like today. And just wanted to share like one of our first viral video. So if you guys know what Reddit is, it has like communities, but it also has this front page. It's called R Popular. And this was one of the first videos that hit R Popular after a few months of launching it. It was like a monumental moment for us. And this kicked off a lot of growth in Reddit. And this video got about like half a million views, and which made us really feel good and move forward with our plan. So what does the stack look like today? Excuse me. So I'll give a very quick overview of like the whole end-to-end stack, and then walk through in depth for each one of them. So the client, the mobile or web or mobile or web, they request R2 for a signed lease to upload the video, right? And then the video gets uploaded to one of the temp buckets, and I'll talk about why we needed the temp buckets in a bit. And once the video is uploaded, we do the kind of the validation and the security checks that we need to run on these videos. And then the video upload queue, which is right over there, which helps with the validation and moving from the temporary bucket to the permanent bucket. And once the video gets to the permanent bucket, it fires a S3 object creation event, which invokes the Lambda over there. And the Lambda has a bunch of presets set, and then it kicks off the transcoding job. And once the transcoding is done, it drops the video into the transcode bucket, right? And then once the transcoding job is done, based on the results, success or a failure, the Elastic Transcoder sends a message to via SNS through SQS to say the job was done and if it was success or a failure, which our ETS completion queue picks it up and notifies the user. This is kind of like the overall flow for what the Reddit video pipeline looks like. Oops. And this is just a zoomed-in version of just the transcoding pipeline piece. Highlights the different Amazon management services that we leveraged for building the transcoding pipeline. And with that, so let's zoom into individual components in the video pipeline and see what happens in each of those components. So the first one, the client upload. The interesting pieces here were like, because we used this temporary bucket, we needed to get assigned URLs from S3 for the client to start uploading the video. We used transfer acceleration enabled, which helped us get a really impressive upload performance by leveraging edge locations from CloudFront, sorry. And of course, we used multi-part uploads, which enabled us to upload a single video into multiple parts, and then S3 gets them all and then gives back one single S3 object. This enabled us to do uploads in parallel, pause them, resume them. This kind of was really interesting and important for us because when you're talking about mobile network connections, when you go into a spotty network area, it's easy to pause and resume the upload so that it doesn't get, the bandwidth doesn't get wasted. And the last one, as I mentioned, we used a temporary bucket with the TTL of like about a day. I'll talk about that in a second. But it's primarily to delete unprocessed videos. So this is kind of what happens in the client upload side of the video pipeline. Sorry, yeah. So once the video is uploaded, we go look into the video validation. What happens once you get the video into the temporary bucket, R2 returns a WebSocket to the client. So the WebSocket was really important for us so that we can know the current status, and based on the transcoding job moving to the perm bucket or the job is done, we can refresh the status of the user or status of the post and send back messages to the user. And once the WebSocket is created, a draft post is created. Like as I mentioned earlier, we don't want to create the post yet till the video is done. And the video is the video upload queue, which is over there, queues the video which basically contains the code for validating and moving the video between the temp bucket and the perm bucket. The kind of validation we do are on the size, the length, and also on we can do some security checks to make sure the video headers are the right things that we are looking for. And then once the video is validated, we set the object metadata with interesting metadata information that we want to set on the S3 object. For example, if the video is a GIF or a video, or just like a normal video. So this metadata is really, really helpful because that metadata gets passed along with your object through your entire transcoding pipeline, and then you could leverage that to build interesting things like either our own analytics or try to measure and for tracing. Sorry. Yeah. So why did we need the temporary bucket? So as I mentioned before, like the experience was like you need to upload the video before the post gets created. So there was a use case where like the user might just upload a video and then just walk away before creating a post. We didn't want to just let them orphan videos stay around. So we built the temporary bucket with the TTL, like a shorter duration shorter duration for the TTL, and so that we can just clean them without any overhead. And this also applies for failed validation videos. Like we upload the videos and then we run our validation or community rules, and the post gets rejected. So we just go ahead and remove them. Also, then we decided to increase our the TTL timeline to a day because we wanted to support disaster scenarios. When you have an outage as the video is uploaded, we didn't want to lose the user data till the outage is recovered. So we landed on having a day's long worth of the TTL on the temporary buckets. And so we had 3 different types of buckets. The temporary bucket is what we use for the uploading and validation. And then the permanent bucket is where we store the original video as it was uploaded from the user. So we obviously needed different kinds of permissions on these the buckets. The temporary allows you to upload video from externally, but the permanent bucket has the original video. So we had different permission settings on them, as well as and the transcode bucket is where the video gets served once the elastic transcoding is done. And one thing which we found really interesting was the caching. So we initially set up like really bad cache headers, and then video is something which quickly adds up. The bandwidth really quickly adds up. So it's really important to get caching right in this case. So now that we have uploaded the video, validated the video, what happens next? Let's go through that. This is where the interesting part of the AWS Lambda comes in. Once the video is pushed to the permanent bucket, S3 fires an event, a notification with an event type. And so you can configure different event types to AWS Lambda functions. So once these events are fired, the Lambda picks up the event data as a parameter and then starts using it for its processing. And we use, for the metadata extraction, we use media info binary. Metadata is similar to like audio, the height, the width of the video, and things like that, the bitrate and resolution. So we use media info for that one. It was so simple to just do a shell out via subprocess to call into the media info binary. And also the next thing was setting up the expected outputs because we needed different resolution videos we set them as presets on the Lambda object. And also the transcoding pipeline supported multiple pipelines for performance and for performance reasons. So the Lambda also supported load balancing on that one. So this is a code sample to show the various presets that we used and how easy it was to map these presets with the metadata. So it was very easy to change the preset by replacing the preset ID with the preset that we are looking for. And so this enabled us to try out different presets to get the right user experience by looking for the quality and the performance and the time it takes for getting the right resolution. And this is a code sample on what a Lambda handler looks like. One of the first things the Lambda handler does is to get the right pipeline. We use a random function to pick to do load balance between the right ETS pipelines. And we also pick the outputs. Outputs in this case are, again, like the different preset settings. So if I upload a 480p video, it is essential that we only downscale it to below 480. So we're never going to try to transcode it into a 1080p video. And the playlists in the code, you see, those are basically the manifest, like either the dash or the HLS manifest, and which basically outputs it to the different containers that they are associated with it. The playlists are really important because these are downloaded by various video players and used to determine the best bit rate for adaptive streaming. So it was important to get that right as well. And we used Amazon's Python API wrapper to queue the job with the job settings into the queue. And so this is where we pass the user metadata, which kind of tells like the metadata around the video. So one of the examples I coded earlier was like tell what type of video it is. And this is kind of interesting, right? Like because the Lambda handler passes on this metadata throughout our transcoding pipeline, which helps us to manage different settings. Like, for example, we kind of wanted to experiment, like, OK, if it's a GIF-only subreddit, high-quality GIFs, can we have a code path or a request path which is optimized for that kind of flow? So AWS Lambda lets us do that with like the metadata setting. And we also had some logging information, which I'll talk about when I talk about the monitoring in a bit. Just want to also call out how deploying Lambda was pretty straightforward. It was as simple as running the command displayed there, and which creates a zip file with the media info binary and the Lambda handler, and then zips it up. And the zip is get uploaded to the Lambda, and to deploy it in the new Lambda function. So this could also be integrated with the build step process, so you can, as you merge code in, a new build gets, or the new zip file gets generated. Using AWS Lambda was like saved us like a ton of overhead for our like just in general managing all these services, just having only one engineer work on this the entire time. So with that, let's talk about what happens in the Elastic Transcoder. So like as I mentioned earlier, like if we had to do this in-house, we had to build our own FFmpeg cluster, which is going to be a really painful process. So this was a lifesaver for us. And we were able to build a whole end-to-end Reddit video pipeline in close to 4 months with a couple of engineers. And this was one of the key reasons. So like basically the transcoder produces two of the manifests, HLS and Dash. And it was also extremely easy to set up multiple pipelines because we needed the multiple pipelines for performance reasons, which I'm going to talk about it in the next slide as well. And again, as I mentioned earlier, one of our key requirements were around privacy, that we need to strip out the geotagging data. And the transcoder helps us strip out the geotags from them before it drops into the transcoder bucket. And so the most important thing for us was around the processing time. And with the type of video that was getting uploaded to Reddit, what we noticed was like our P90 was on less than 30 seconds, which was like pretty significant for the scale of Reddit. And the other interesting feature that the Elastic Transcoder gave us was super handy was generating a poster image, which is basically given a video with a bunch of frames, what is the thumbnail for the video. So this enabled us to prototype really, really quickly. And it was like almost like plug and play, and we got it working. And the last piece was around having multiple pipelines. And as I said, it was more around fault and performance reasons. When you have like a really long videos, there's a potential that the queues can get really, really long. So we had 2 dedicated pipelines for video and also dedicated pipeline for GIF. Because GIFs were like, because of the time, like about like less than a minute, they were like really quick turnaround and shorter videos. And the metadata that we tag on in the Lambda Handler is the one which helps us route to the right appropriate queues. So once the video transcoding is done, I talked about like the notification message that gets sent out from the Elastic Transcoder. Here is an example of what that looks like. We can get to see the job status, like the settings. Was it a failure or a success? Along with the user metadata, the job settings that was initially the job was created with, as well as the different outputs, the number of outputs, and the manifest playlist. And then again, the error codes and all the information that is needed for the client to give a reasonably good experience for the end user. So once the transcoded video is dropped into the transcoding bucket, ETS passes the message which I just showed in the previous slide via SNS to SQS. And we built our, in R2, we built our own ETS completion queue, which basically pulled this information, looked at the metadata, and was able to, depending on if the job was success or a failure, it did a few things. If it's a failure, it just notified through the WebSocket to the clients that it was failed for so-and-so reasons. And if it's a success, it tied the original post to the transcoded output and then queued it for re-indexing in our listing service. So that was from the client side, or from the Elastic completion queue. And again, this is another call out for AWS infrastructure, where we were able to build this, the glue between our job queue that I mentioned in our original Reddit architecture, where we had the job queue to do some expensive operations. We were able to tie into our existing job queues using, with Elastic Transcoder using SNS and SQS. It was super easy to build it. And all we had to do was build like like a scalable solutions, and we had, I think, 3 queue consumers, and which was able to handle the Reddit scale. And finally, so that's like kind of the whole end-to-end flow of what we just looked at. Client uploads temp bucket, WebSocket comes back to the client, validation happens, moves to the permanent bucket, and then a notification is triggered by S3 to Lambda. Lambda takes in defined presets. Once the transcoding job is done, Elastic Transcoder via SNS sends a message to SQS and drops the image in the transcode bucket. And then the ETS transcoding completion queue picks up the message and either sends a user the error message, or it sends a message saying this is the listing is live, and queue it for indexing. So that's the overall flow of what the Reddit video looks like today. I mean, when building any service, like monitoring is extremely, extremely important. And one of our key requirements was observability. And so monitoring leads us to look at alerting. And like when we initially started, we didn't have multiple video pipelines. We saw like the queue size were like increasing quite a bit. So then we made a choice to like separate, have dedicated pipelines. And so we got a lot of metrics out of the box for free via CloudWatch. And it was really extremely helpful with all the managed services. I'll talk through some of the interesting metrics. And the other key thing which kind of worked out in our favor was getting it integrated with our existing monitoring and alerting solutions was really, really important. At Reddit, we use Grafana and Graphite. And So all these things were integrated there. But currently, we are switching over to Wavefront with all the new Kubernetes world that Reddit is moving towards. And on top of that, like, we also needed some kind of custom instrumentation that did not come out of the box. So let me walk through a couple of those examples. So these are some of the metrics that came out of the box. I would say like the top two ones are kind of the most interesting ones: the jobs completed and jobs errored out, and also like the standby time, which kind of tells us how long the queue is and how long individual objects are waiting to be getting transcoded, which is kind of an important thing to look at. And this kind of helped us go into multiple pipelines when we first built our pipeline. So as I mentioned, like, we also needed a couple of instrumentation that was not readily available from CloudWatch. One of those things are it's the transcode duration. As I mentioned, like, one of the key requirements when we started was like really extremely fast processing. And so how can we add some custom instrumentation? So I just want to throw in like a code sample on how we were able to measure this, measure the transcoding duration. So again, it comes back to, like, all of this is running in the ETS completion queue, which is our integration point between SQS and R2. So remember, like, the original user metadata object that you set when you created the original Lambda function that gets passed around the entire pipeline comes back to our completion queue. So with that, you know all the job settings and like the different outputs and the initial start time. So we were able to add a duration with by also looking at the other metrics, like the height, the width, and what was the bit rate. So which helps us kind of coordinate, like, look at it from different dimensions. Like, okay, for bigger videos, high resolution videos, what is the duration? And we also added the standby time, which kind of tells how long the video was waiting in the queue before the transcoding started. So with those two data, we were able to plug them together and get like an approximation of the transcode duration time. So with this, like, this is one of the custom metrics we added. So we can think of adding metrics that are really interesting from a product perspective or from a technical perspective. And these are a few of the metrics that we got out of the box in SQS and SNS. Nothing really interesting, but like, we just had a bunch of alerting and monitoring set to make sure the system was fine. Simple things around number of messages deleted, received, sent, things like that. On the SNS side, it's like the number of notifications pushed and delivered. So with that, I just want to walk through a couple of slides on how did we roll this out and what are the results looking almost after a year since we launched this video platform. When we first started, like, one of the key things that we knew about Reddit is, like, Redditors are changeovers. Like, they are like, had really good experience trying to build the redesign and it was a really interesting experience. So video was like the first time we tried to push in a new experience, and the way we took there was, like, we worked with communities that were like video heavy and GIF heavies, and they're more interested in trying out new things. So gaming communities adopted the videos. Of course, we got like a lot of inspirational feedbacks once we launched. I'll read a couple of them. Shitty video site that doesn't work on any of my 3 browsers, or Alien Blues built on browser. Or the other one, this video shit is awful, opens in browser through Reddit is fun and slow as hell. So it's fun working at Reddit sometimes. So, so like, one of our product managers, Emon, he went and looked at through a ton of these feedback. And one of the interesting analysis he came back was that like, most of these users who have been making these inspirational feedback were using our third-party clients. So turns out the way the native video platform, the mistake we made was, like, we did not coordinate with our third-party developers so that they can use the adaptive streaming technologies that we use so that they have a really good experience for those users. So once we found out that, like, we were able to go work with the third-party developers for like 2 to 3 months And once they added it, it's when things kind of started turning around. What we started seeing is like, we kind of started seeing new kinds of videos that didn't exist anywhere else before. So when we launched video, like the Reddit video, we were curious, would it take down like other third-party sites videos that's getting plugged into Reddit, but kind of see like new types of content getting created within the community-centric ones. So this one, the first one on the left is a dude is getting like videotaping his head and asking what type of haircut he should get. On the right is someone asking feedback on their golf swing. So it was really interesting to see people adapting it for interesting use cases. And then finally, after like going through like a lot of this fun feedback, it was like we just reached a monumental moment, like I want to say like a month back, when Reddit video reached like more than 1 billion views a month. It was pretty phenomenal for us, and it was really, really good. And so for people who haven't watched Infinity Wars, Avengers, this might be a spoiler, so I apologize. So in the end of the movie, you know what happens. Thanos snaps his finger and half of the population disappears. So there is a community in subreddit in Reddit called Thanos Did Nothing Wrong. And there was a petition there which was like, ban half of the users in that subreddit. So obviously the things got upvoted and became really popular. And it was Thanos himself sent a message and he snapped it. And I believe it's on July 6th, we banned randomly half of the population. So it was, I said it, like Reddit has a really unique way of bringing creativity. We give them really simple tools. So that's one thing I really love about working at Reddit. It's like the community powers Reddit. And looking at some of the stats, obviously we see about 60 to 70% of the usage coming from our mobile devices, 45% from iOS, and 22% from Android. And the desktop is like 24%, and like mobile web, we get around 10%. And the other interesting one is like the graph is starting at like July 1st and going up to like August. So you see a steady increase, and we reached up to like almost 20% of our videos that are hosted in Reddit are native videos. And I just want to point out this particular thing which started at October and went on to like December. This is kind of the phase when we were getting all those inspirational feedbacks, just to tie it back. So we were like, that's the time we were working with all the third-party developers to bring their apps up to speed. And we were very particular about bringing communities in front when we were rolling it out. So we didn't roll it out to a lot of users. And it took a tipping point earlier, beginning of this year, and it's been growing linearly. So what are some of the lessons learned? On the technical side, minimal infrastructure. As I said, like we have 1 billion views right now. There's only one engineer working on it right now. Like literally one engineer working on the Reddit pipeline. There's only one engineer working. And thanks to the AWS, we don't have to worry about the infrastructure. And observability is key. Which kind of helped us make some interesting product decisions around like load balancing our pipelines or knowing when we are running into errors. So always keep that in mind when you're building it. The other one, which the thing which is key for like some of the startups and these product companies are like to focus on the core user experience. Like working with AWS ETS, we were able to focus on our core user experience problems instead of worrying about what the infrastructure should look like, what should be the transcoding pipeline. And this helped us focus a lot of our time experimenting on like quite a few different things. Like for example, the segment lengths on the manifest, like how long should it be, what will be a right ideal experience, trying to get the adaptive streaming working the perfect way for slow connections. And again, for HLS, follow the guidelines. It's like Apple defines strictly what needs to be done. For Dash, you need to play it around and get the right settings. And in general, video plays have been really hard. Like in terms of the clients, we have Android, iOS, web, mobile web, and third-party mobile apps as well. So getting those things took a lot of our time, and we were able to focus on the key issues than worrying about our infrastructure and scaling it. And so AWS Managed Services was a perfect MVP for us, and for most of you guys, I would believe we were able to get it right. One of the other things which we learned by paying us a little bit more money was around caching. We messed up our caching initially, and then when we went and turned it around, we were able to reduce our cost by 1/5. So that was really good. And the last one is, again, we were able to leverage the metadata to the object to pass around the Lambda function to learn a lot, or sorry, not to learn a lot, to help make custom changes, integrate with pieces that are like, it could be our analytics or it could be our own data pipeline. So we were able to do all those things. And some of the lessons learned, but these are not technical. This is purely from rolling it out to a community like Reddit. It was around, first we identified a video-friendly communities around gaming, GIF, memes. We obviously prevented NSFW. We didn't want to go into that. And like, it was, the struggle was getting the first initial viral content or the initial advocates for your video type. Once we got like these early adopters and people started using it, and when the video started coming up into the popular page or the front page, it was kind of interesting to see like people started adopting it. And in Reddit, we have user profiles, and we rolled it out to all profiles. And we kind of got interest from like famous publishers like Time, Washington Post. Time also made a video with like one of the Sonar Eclipse, I think. And then it got like a ton of votes. So it's kind of interesting to see the whole rollout tactic around starting small, here, get as much feedback as you can, even if it means slowing down your rollout, take in all the feedback, fix the issues, and then keep rolling it out. And this is like a key lessons that we took in, which we kind of applied in our Reddit redesign rollout as well. So, and so we have large partners working with us right now. And finally, it's like it was launched to all as Safe for Work communities, I want to say earlier this year. And by like last month, we hit like 1 billion views. And like with AWS, we just need a single engineer to manage the whole process. So with that, thank you. Any questions?
Do you have any problems with permissions for the uploads? Like for normal posts, you can go through a service that you manage, but now you're allowing customers to directly upload to S3 buckets. Do you encounter any problems with that? Like now, certain people uploading bigger content, stripping.
Okay, I'm not sure I have a correct answer for you now, but like let's just catch up offline. I'll connect with you. Someone can answer that one. So for some of the things like the community validation, we have our own framework. Like to run through our automod rules, community rules, we have our own framework. For the actual validation on the video itself is done through the media info, where we get the metadata around like the size, the duration, and things like that from the media info binary. So that's, we do have a team called Trust and Safety and Anti-Evil in Reddit. So that one is completely out of my scope, but let's connect offline, and I'm happy to connect you with someone because I wouldn't be able to do justice for that question. So.
What were some optimizations you made to actually serving the videos after transcribing them, actually serving them to users?
Yeah, so some of the optimizations that we did were around the segment size. And like initially when we started, like we had a couple of, we started with like only 2 to 3 resolutions that we saved. And we tried out through a bunch of manual testing. Then we came back, and then we came down to some of the predefined presets that I had, like I think 5. So that was one, the segment size. We started off like with small segment size for adaptive streaming. And what we found out was that like it was taking, because of the small segment size, which means more bandwidth, so taking a longer time. So we did end up increasing our segment size to optimize for it. So those two things were things I would probably call out. Sorry, say it again? Yeah. Setting the right, let's catch up after this. I don't have a right answer for that one.
So there's a lot of reposting on Reddit. Have you guys thought about ways to identify videos that were already uploaded and just pull that file?
Not yet, but like that's something in our, so probably in the team that I'm running right now. So I'm running the machine learning platform. At some point we might have to look at it, but it's not something we've been actively looking at. Could you say that?
Streaming your videos peer-to-peer.
Okay.
Instead of going right to the cache.
That's an interesting idea, but like I'm not part of the team anymore now. I'm in the machine learning team, so yeah. Yeah.
You mentioned in your talk on uploads there was some degree of validation of the video. Could you go into a little bit more detail about that?
Yeah. So once it gets to the temporary bucket is when we start looking at our a few things. We use the media info to get the metadata on the video. It's like the size, the duration, and different the headers of the video. Those are the things that it's in the valid set. Once that is done, there is the next round of validation which happens, which are specific to Reddit. Because in Reddit, like if you're uploading, if you go to a community which only allows you to upload GIFs, you should not be uploading videos. Or communities, like there are like a lot of community-specific rules, and also auto moderators, which are like community rules are like defined by moderators of the community, so they come and remove those posts. But they also have predefined settings called auto moderators, which come and remove them as well.
Okay, so business rules, not necessarily security of the actual uploading content.
Yes. Yeah. Sorry.
Yeah, I got one more.
Sure.
So there's a startup called Convos that's really interesting where you can reply with video, like a webcam reply. So it's you responding with words as opposed to writing it. And I thought that would be an interesting idea where there's like a webcam button or something, and you could record a video to reply. So Ask Me Anythings are huge on Reddit. But I was wondering what you thought of that idea, or if that's something to take back.
That's an interesting idea, but like I think the way, like today we don't support media in the comments, right? Like, and we take comments as like comments are like the core part of Reddit, and we want to be mindful about how do you want to get there, right? It's when I say conversation, it's more on the discussion that's happening, and like the videos are like more interesting as a post type rather than as a discussion type. That's my personal view. Yeah.
So you talked a lot about the metrics that you're collecting from your peer. Could you also talk a little bit about how you guys handle logging and some of the tooling around logging and how you get access to, I'm sure, lots of logs each and every bit of this process?
Again, like that's like I'm happy to discuss with you offline, which is something like we have a different infrastructure team. Like I said, we use the common frameworks, which takes care of a bunch of the logging, integrating with our data pipelines, the whole system. So that's not something I was responsible of. So, but I'm happy to connect you with someone.
You have different queues, a different queue for video validation and a different path for video uploads. So how do you sync between the two? So if a race condition as well as where you pick up, so you have a queue for validation that the queue comes up before the actual video is uploaded in the temporary bucket.
So, okay.
You showed two paths, right? One was the validation part and one was
No, the video, like the validation happens after the video is in the temporary bucket. It's a sequential process.
Why do we have a different queue for that video upload?
The video upload queue is for when you have multiple videos in the temporary bucket and those needs to be validated. Like it could be multiple users coming in. So once you upload a video, it goes to the temporary bucket and then it goes into the validation queue. But like, and then the queue is for multiple users trying to upload at the same time.
Would you consider using like recognition or any other sort of image metadata extracting service?
So we like that's kind of in our probably in our like down the line roadmap as part of some of our machine learning techniques. So I currently run the machine learning team and just gave a talk about like how we use machine learning. Images is something we do consider, but like primarily our focus is around natural language processing right now to understand the text and content. But that's something we might consider in the future.
You mentioned that R2 is the original Reddit. Any plans on breaking that apart?
Yeah, I personally would want to. Yeah, the way we think about that is like I found out, like I led the redesign effort and I found out there is a site called i.reddit.com which still runs, like which is like way back site. And R2 from the client perspective, like the old Reddit design, that's something which is we're gonna let it go, let it live forever. That's kind of what our CEO promised when we went with the redesign. But in terms of the backend services, we're just slowly plugging our way into getting into microservices. And there's another one of the API teams that is responsible is slowly moving into GraphQL. So that's something we are working on as well. Well, like we don't have a timeline on something.
Have you considered using the Amazon SQS instead of Rabbit in the queue?
I'm pretty sure we should have done it, but like it was something we've already been using for.
I'm just curious if there's enough throughput in SQS compared to a Rabbit.
Yeah, potentially, but I'm not. But I'm happy to connect you with like this question and the previous question you had around like with the right person for that.
Are you going to upload? That's why I guess that's linked to Reddit, so we can upload.
Sorry, say that again.
Are you going to upload the video of this session using this process so we can upload it later? You can post this on Reddit.
Which this one? I probably should, right? Yeah. Yeah, it's like well within an hour. Hopefully the video is like less than a gig, so. Awesome. Cool. Thanks, everyone.